Well, hi, everybody, and welcome. We will start in just about 30 seconds as folks are joining us. You are in the right place. We are at the official launch of the ASHRAE Decarbonizing Hospital Buildings Guidebook, also known as the ASHE Decarbonizing Hospital Buildings Guidebook. So just as folks are joining, I just wanted to say that it is a pleasure for me to be here. My name is Troy Savage, and I have the privilege of hosting this launch party. I'm calling it a launch party, and I want you to think of it as a launch party too. If you haven't already, you might want to get your favorite celebratory drink for when we do the toast of this launch. I today will be drinking this amazing Wegmans sparkling grapefruit water. I'm very excited about pouring this out and having a glass. Whatever your choice of beverage to cheers is, I hope you'll grab it. In a couple of moments, we will celebrate in that way.
Hey, where's my lunch, Troy?
Very soon, very
I'm
soon.
expecting soon.
And so, as I said, my name is Troy Savage. I also had the privilege of being able to project manage this amazing group of authors as they put together the guidebook. I won't tell you too many stories, but if there's time, you might get a story or two. You're in it for a treat today. I know it's Friday the 13th, a lucky day. And it is a lucky day because we will hear from the team of people who came together to produce guidance on arguably the greatest challenge for our industry and society at large. We do have a couple of giveaways today. I already mentioned that you'll get to drink your favorite bubbly. Some other housekeeping items. Feel free to populate questions in the chat throughout the program. We'll strive to answer as many as possible in the latter half. I'm thinking of the latter half of this really as a fireside chat. You get the opportunity to ask questions to four really spectacular people. And so I hope you'll take that opportunity. And before we turn to introductory remarks from Kara Brooks, I just want to highlight that this team, the author team, as well as the task force, was given a particular challenge. And that was the challenge not of designing a partially decarbonized building, but of designing a truly decarbonized building, and therefore, in some senses, as I suspect they'll say, an all-electric building. So they weren't going for half measures, they were stepping all the way in. And so as we celebrate today, I hope that you'll step all the way in first. I have the opportunity now to introduce Kara Brooks. I think is Thomas is not here. So I have the opportunity to introduce Kara Brooks. She is the Senior Associate Director of Sustainability for the American Hospital Association, ASHE. Kara Brooks spearheads strategic leadership, advocacy, and program development for the association's sustainability initiatives. With over 20 years of experience in environmental sustainability and energy engineering, Kara is a recognized expert in her field. She actively contributes to numerous national panels and committees, helping to develop codes and standards for the healthcare built environment. She holds a Bachelor of Science in Mechanical Engineering and a Master of Science in Business Management from Colorado State University. She also serves as a subject matter expert on the National Academy of Medicine Action Collaborative on decarbonizing the U.S. health sector and participates in various other national technical standards committees. If you've ever met Kara, you will know, in addition, that she brings an infectious energy to her work. You can feel it even over Zoom and especially in person. She brings people together and helps them to identify and overcome challenges. And so I'm excited to introduce Kara to bring us a welcome message.
Thanks, Troy. Appreciate the opportunity. I know Thomas it has his picture up here. He was going to be on here too. I don't think he was able to join. So I will speak for ASHRAE as well. First, we'll start with how this book came about. And really, it came about as a result of the initiatives that ASHE and ASHRAE both have on decarbonizing. Both organizations continue to lead in this space for the healthcare sector. We really wanted to look at hospitals specifically because they are not typical buildings. As most of us know, they're 24/7 use, they're highly energy efficient or energy intensive, And so we thought that they had some special considerations. In addition to that, they're also highly regulated. And this can make decarbonization even more challenging. So we felt that there was specific guidance warranted for the hospital sector. Then talking about why this is important, there's a few different reasons. First of all, just wanted to point out that we did focus on North American hospitals, um, and really wanting to prepare the healthcare field for decarbonization, especially as they're embarking on new projects for building and renovation and major renovation projects. There's a lot of regulations out there in different jurisdictions that are charging buildings with decarbonization and electrification. And so really felt that it was important that we address the hospital sector. There's some special features in the book where we identify where certain emissions fall in scopes 1, 2, and 3, and help to really categorize those healthcare spaces. Really designed this book for a variety of audiences, including designers and engineers and architects, also hospital facility managers, and importantly, the hospital planning, design, and construction team. So just talking about why we just did this now. I think there are a few reasons. First and foremost, the fact is that the healthcare sector accounts for 8.5% of US carbon emissions. And we're really encouraging the field in addressing those emissions. We had a lot of feedback from industry that suggested that we go down this road and really start to address this decarbonization in new buildings. And finally, there's a global movement toward decarbonizing the healthcare space, starting with the National Academy of Medicine. We also have the Joint Commission certification for sustainability, the new International Joint Commission certification for sustainability, and finally, the interest at CMS, and particularly within their Innovation Center for requesting voluntary reporting starting in 2026. So we felt like the timing was right and that this was very important work. And I also will just close my little section with thanking the authors specifically. They did a fabulous job, and this was a labor of love that I think we all enjoyed working on. So thank you.
Excellent. Kara, thank you so much for those great words of introduction. It is now time for our first trivia time. You can see the trivia question on your screen. I believe the way this is going to work, that you'll see the poll question, and as you answer the poll, those of you who get the answer right will be entered into a drawing for a free copy of the guidebook. This is a pretty exciting prize. Thank you to ASHRAE and ASHE for providing the prize. And so we'll see how many of you get the answer right, and then you'll be entered into a random drawing. Great. As folks are continuing to enter their poll answers, I will go ahead and introduce the Decarbonizing Hospital Buildings Task Force. The authors actually had a lot of support, and we're very thankful to the work of the task force led by Tim Peglow. The task force met for months, meeting at least every other week. They even provided feedback and comments to the authors just after Thanksgiving. The authors went through a lot together. We had lots of jokes. We supported each other, and the task force supported one another when various personal challenges came up. And ultimately, every person on the task force was committed to the work of this guidebook. And so while the authors' name are authors, the task force really did play a prominent role in putting this together, including making international connections with experts so that the authors could get the best of the best thinking from around the world. And so I can't see everybody. Steve Gutman, I see you on. So thank you. I can't see any of the other author or task force members, rather. I think of you as authors too, on the screen, but we're just thankful to each of them. So Tim, Steve, Raji, Amit, Kara, Shanti, Travis, and Kim, thank you. All right, and I think we are about to end the poll, and I encourage all of you to get your celebratory drink. As I mentioned, I have my grapefruit bubbly water here. I'm going to pour. And I know this launch party is on Zoom, but my hope is that 80% to 90% of us can come on camera, at least for this moment, as well as for hopefully for the fireside chat. As we toast this work, this launch of the ASHRAE Guidebook. So we'll wait for a moment for others to bring their cameras on. Great, there you go. I see Kim. Hi, Kim. Thank you for serving on the task force. Okay. All right. Well, everybody, cheers.
That isn't a carbonated drink, is it? Haha.
It is a carbonated drink.
Oh no.
Excellent. Cheers. It really is a neat moment to be able to celebrate the launch of the book. I know we're not smashing a champagne bottle against the hull of a ship, but I hope that you enjoy this moment as a moment where we can together take a journey on decarbonizing our new buildings. And now I have the privilege to introduce our authors. So first up, you'll hear from is Heather Burpee. She's a research professor at the University of Washington Integrated Design Lab. She's a distinguished scholar in high performance buildings, specializing in energy reduction and healthy indoor environments. Heather's work integrates practice, research, and education with a focus on both qualitative and quantitative building aspects, including health impacts and environmental synergies. And I can say she just did an amazing job of helping to lead and move the guidebook forward. The success of the guidebook is partially based on her very strong and important work. And so, Heather, the floor is yours.
Well, thank you, Troy. And thanks everyone for being here today. This is really exciting for us. The section that we're each going to talk a little bit about a section of the guide. And so first we're going to talk about thermal energy. Thermal energy was really at the center of a lot of our discussions. And the big premise is outlined in these 5 bullets, and these are laid out in the guide. And the first idea is don't generate new heat. We'll talk about that in a minute. Use heat pumps to capture and reuse heat. Store excess heat when you don't need it. Use it later. Don't burn anything to generate energy. Electrify everything. Walt's going to talk more about that later. And then do all of these things using as little energy as possible. So let's go to the next slide. One of the reasons that thermal energy was such an important part of the guide is that hospitals that have paradox. They use an enormous amount of energy, thermal, to create thermal energy. And often that's using fossil fuels, so natural gas. And it's really what we characterize as a disconnected energy flow. So natural gas goes in, the heat gets used, and then it gets exhausted as a waste product. And so we turned that on its head, and let's go to the next slide, to say, let's capture all that heat. Hospitals, we talked about them as exothermic kind of animals, for example, where they generate more heat than they need. And so let's capture that heat and utilize it within an energy flow system. And so this diagram on the right shows that circular energy flow, where the electricity then goes to places that actually generate heat. We capture that heat so that there's no combustion in the system. And then the heat is moved spatially and temporally using heat pumps and thermal energy storage. which Jim's going to talk a little bit more about some specifics and nuances with that. So don't generate new heat is a big premise of the guide. Let's go to the next slide. There are areas where we need higher grades of heat than for the heating, cooling, and ventilation air for the hospital. And so those are also additional sections in the guide. So for example, service hot water, sterilization, humidification, it can be difficult to think about providing heat for those systems without natural gas, and the guide addresses those, as well as making all electric kitchens and how to address laundry and labs. So with that, I'm going to pass it on to the next author, Jim.
Great. Well, I have the privilege of introducing Jim. Jim Crabb is principal and senior mechanical engineer at Mazzetti, among other roles. He led the engineering teams that designed the first 2 hospitals in Georgia that use waste energy for all building heating and hot water production. He's advised the World Health Organization on pandemic ventilation best practices and is a regular author on healthcare decarbonization. Since I get to host today, I'll also say that Jim is one of my favorite people in the world. And so it is my privilege and honor to introduce my friend and colleague, Jim Crabb. Jim?
Thank you, Troy. And I will say it's a particular honor for me to be on this book with Heather, because Heather was a part of the start of my sort of decarbonization journey. After many years of being a mechanical engineer and putting in boilers and enjoying putting in boilers, I saw a presentation that she was a part of that sort of made me realize that we have all this extra heat in our hospital buildings, and maybe there's a better way than burning natural gas. Started off really for me as energy savings, but the implications for decarbonization are obvious. So Heather talked a little bit about capturing that waste heat and reusing it. And that's a really important thing. As engineers, at least in my past, it was relatively easy. If you needed cooling, if you had too much heat somewhere, you put cooling in. And when you have too much cooling or extra heat, you just throw that away. When you need heat, you just pull it out of the steam system and steam or hot water and apply it wherever you need. This is more challenging than that. It's not as easy as the old days. It reminded me somewhat of when my boys were in scouting, and we'd be out on a camping trip at a camping site, and one of the boys would go up to the scoutmaster and say, what do I do about this? And he would just smile and very patiently say, well, look around, use your resources. And that's kind of where we are today. We all need to be scouts for what are our sources of heat. In the summer, we know we've got plenty of heat. We're running cooling towers or some other system to throw that heat away. In the winter, but even then, as we've always done, we're burning natural gas to make new heat somewhere inside the building, which we then have to remove with that same cooling system. So we can't do that anymore. It's relatively easy to understand how you recover heat in the summer and don't have to run boilers, but it gets cold sometimes, and more so in some areas than others. And so our estimate is that think about roughly 80% of your heat, 70 to 85% of your heat, even in fairly cold weather, can come from that energy recovery. But there's a gap still that you're going to need to make up. And so we start to think about what are our tools. Direct air-to-air heat recovery is one of the primary tools we need to use. That's a very direct route to pull heat out of the air. Chill water heat recovery is kind of the basis for all of this, with heat recovery chillers and heat pumps. Solar thermal comes into play here. It's another opportunity to pull heat when you need it, but it won't always be available. And so one of the things we look at is storing some of that excess heat when we have excess, and storing those acorns for later use. We think of thermal storage in terms of water storage tanks. Chill water and hot water storage have been used pretty commonly. At the scale we're talking about for a seasonal kind of storage, that would get quite large. and will have its limitations. One of the systems we've used is borehole thermal energy storage, and that's using what it amounts to a very inexpensive medium, which is the earth. But the heat exchanger turns out to be fairly expensive because you got to drill holes into the earth to store and then access that heat. But it's a very effective way of doing it, and that, in fact, is what we've done in these two hospitals in Georgia that has allowed us to transition. And then there are other things that are a little more cutting edge, so to say. Phase change, there are phase change materials that we can use. Ice storage is something we've used for a long time. That could be a tool in the kit. And then one that might seem outlandish to some folks, which is recovering heat from our wastewater out of our buildings. There are systems that do that now, even at a municipal scale. There's a system being built in Toronto. I think it's Toronto right now. So we're going to have to be more creative than we were in the past and use the resources at our disposal.
Excellent, Jim. Thank you. Thank you very much. Next up is Walt Vernon. So Walt is the CEO of Mazzetti, an employee-owned benefit corporation with offices across the US and in India, focused on helping healthcare plan and implement carbon reduction strategies. He's also the founder and CEO of the Sexton Foundation, a non-for-profit committed to developing sustainable infrastructure for health facilities in low-resource countries and spurring innovation in healthcare around the world. Over to you, Walt.
Thank you, Troy. Hopefully everybody can hear me. This in some ways is a mutual fan club here, and I want to pile on and say thanks to Troy and to the co-authors and to the panel. And really, as I look at the people who are on this little meeting right now, I see so many of you who I've learned from and who I've worked with and learned together with. So I think in so many ways, this represents the work of all of us as we learn together to tackle this problem. So what I wanted to start with, Troy, is somebody going to advance a slide, or do I need to do something? It's just this general principle, right? I mean, if we have a target that we must be 50% less carbon by 2030 than we are today, that is a huge and daunting goal. And it means that every new building, we can't be adding new carbon to the current ledger, because for every piece of carbon we add or other greenhouse gas, to get to a 50% reduction, we got to take away 2 from the existing stock. And that's not so easy. And in particular, when we think about the equity considerations of people in less advantaged countries. So there is an imperative to try to electrify every building right now. But, next slide, as we all know, it's not so easy. And there are challenges with the grid, and the grid not being very clean. So if we electrify, aren't we just taking a sidestep? There are concerns about the capacity of the grid, certainly the transmission system, and how do we get from one place to another? The physical size of electrical switchgear, our systems just aren't designed for that, and the demand factors in the NEC are not our friends right now. The issues of electrifying vehicles, which are adding to loads, and then what do we do in an emergency when the grid goes down and we put all our eggs in that basket? And what I wanted to say really, and what's described, I think, in the book, is that there are 3 things that are sort of working in our favor. The first thing is, for all of these issues, there are workarounds. There are ways to do it in almost all situations. Not always easy, not always inexpensive, but there are ways. The second thing, though, that's really encouraging is the progress that's being made in both innovation technology. I see new things every day and ways to work towards better building. And oops, I'm out of my 3 minutes now. Last, I think, is the fact that the alternate is worse. If we install something today that's going to burn fossil fuels, the cost of putting that in now, even if it's a little bit cleaner than buying from the grid, but then taking it out later when the grid gets greener, is going to be essentially double. And so it's much easier in many respects to pay a short-term cost maybe in carbon now to get what we really need, which is long-run carbon reductions. And I guess the last thing that I wanted to say is we have examples today. You've all read about UCI, of course, and some of the big projects that are now starting construction. There are at least 3 operating hospitals that are all electric. One in Washington State, Peace Island Medical Center, and then the 2 that Jim mentioned that are almost all electric. I think everything except kitchen. So there are examples. It can be done. It can be done economically, but it does take courage and determination. And but it should be getting easier over time as we continue to learn from each other. So thanks to all.
All right. Well, it's my honor to introduce, last but not least, Mara Baum. Mara is a partner at Dialogue, is an accomplished architect and urban planner with over 25 years of experience leading complex architecture and urban planning projects across North America. She's dedicated to integrating ecological and health issues into the design of buildings and cities, striving to create environments that promote well-being and sustainability. I did not know Mara before I first met her working on the guidebook. I can tell you from personal experience that she is brilliant and she is driven and she just did an amazing job of helping the team think critically and move forward. And so I'm excited to hear what Mara is going to share with us right now. Mara?
Well, I'm not sure how I can top that introduction, but thank you, Troy. I am the token practicing architect amongst our group here. Although Heather is also an architect, I'm working on hospital projects all day, every day. And I'm also going to shift the conversation a little bit because the first set of speakers were largely talking about scopes 1 and 2 emissions related to operational emissions. But as we've started to really improve our operational emissions scenarios, embodied emissions are becoming a really critical part of the conversation that for quite a while, the building industry hadn't put a heavy focus on, and that's changing very quickly. I show here that building materials and construction make up a pretty substantial portion of global and US emissions. For those of you not familiar, embodied carbon references those emissions that are associated with the harvest or extraction of building materials, manufacturing, construction, transportation to the site, and then to a less extent, during operations and maintenance, any type of cleaning or refurbishment or renovation, then at the end of life, demolition and reuse of those building materials. For the purposes of this, most of us, and in fact, I would say most ASHRAE members specifically, are really focused on upfront embodied emissions, but ASHE members are probably also concerned with, or hopefully you're concerned with, or you will be soon concerned with, the operational emissions through the full life of the hospital buildings. Next, please. And the guide looks at a wide range of opportunities to significantly reduce those emissions, starting at the very top, like asking ourselves, how can we actually build less? We often can think about building existing buildings and campuses as an investment in time and resources and money. It's also an investment in carbon. And so anytime we have to take a building down and put in a new building or add a building where we might not have needed one, that's a significant addition of embodied carbon to the atmosphere. And so the guide walks through a number of different steps that we can take to try to reduce those emissions considerably. Next. And there are many embodied carbon guides out in the world. This one tries to focus specifically on what is special about hospitals. And there is, oh boy, a lot that is special about hospitals. Everything from the fact that we face additional structural criteria, beefing up our structure for all sorts of various reasons. Concrete and steel are some of the highest embodied carbon materials. Everything from that to all of the extra embodied carbon associated with pharmaceuticals and food and medical equipment, all the extra stuff that comes in and out of hospitals all day long. Now, the guide focuses primarily on building industry related emissions, but there is quite a wide range beyond that as well. Next, please. And the elephant in the room, then not exclusively related to embodied emissions, but the elephant in the room here is resilience and adaptation. This is not a full climate resilience guidebook, but it does address the fact that there are some pretty strong connections between how we think about carbon emissions reduction and decarbonization holistically, and how we think about how a building will operate through the course of the future, as we know that weather patterns are continuing to shift. And so there is a discussion about some of the real significant benefits and synergies between decarb strategies and improved resilience and adaptation, as well as some potential challenges. Walt mentioned, challenging electrical grids. I live in California, so I'm up close and personal with that one. But there are a number of really important ways that we can think about how to approach both problems at once that allow buildings to perform well on day one, as well as on the last day of the usable life of whatever service life of whatever system or equipment that we have in mind. And so these are parts of the guide that are not, I would say, the big punchline, but of course, very important to develop our holistic thinking about decarbonization. And Troy, I'll hand that back to you.
Well, thanks to all of our authors for those brief remarks. Hopefully, they sparked some thinking and you'll have some questions for them. Before we turn to what I'm going to call our fireside chat, we have the opportunity to hear from Thomas Loxley. So Thomas Loxley with ASHRAE is a graduate of the University of Kentucky with a BS in Biosystems and Agricultural Engineering, and then Auburn University with the MS in Biosystems Engineering. He currently serves as staff liaison to Standing Standards Project Committees 90.4, 189.1, and 189.3. As the assistant manager of standards codes, he enjoys working with a wide range of professionals to write new standards and guidebooks for a brighter future. Thomas, we'd love it if you share a few words with us before we go to our next door prize.
Awesome. Thank you so much, Troy. Can everyone hear me okay? Awesome. Yeah, I just want to say a few things real quick. The Guidebook looks so amazing because of the time, effort, and energy that the author team put into this. We had fantastic people from the working group chime in, help out the author group. I thought it was amazing just how everything worked together. And just wanted to also kind of plug this as just one of the first of this series for this book. We have 6 other books in our decarb series at ASHRAE, and this is the first time we've partnered with another organization for this. So partnering with ASHE and getting their input was critical, I think, for the content of this book. We really appreciate our partnership with them. I also want to take one quick moment and introduce Mary Bolton. She's our editor for special projects here at ASHRAE, and she is the reason why the guidebook looks as good as it does, why the layout looks amazing, why it flows, chapter to chapter. So if you'll join me in a virtual applause to Mary, she did an amazing job with it. Yeah, thanks, guys. And Mary, if you're able to turn on your camera, we can see you. Anyway, I just want to give a lot of credit where credit is due. A lot of great people, worked on this, and I think at the end of the day, it's something we can all be very proud of.
Great. Thank you, Thomas, and thank you especially for highlighting Mary. I haven't seen her yet, but Mary's work. I also think I saw Tim and Raji from the task force joined. So if you want to come on camera so folks can see you, that would be great. Oh, Amit is here as well. I see you, Amit. So if you want to come on camera, folks can see you.
Let me. Yeah, can you hear me? I mean,
Yeah, we can hear and see you. Good to
okay,
see you.
good. Okay.
And there's Tim. Hi, Tim.
Hey,
Yeah.
good to see everybody. It was a wonderful experience.
Okay. Excellent. Tim, thank you for leading us. All right. Well, it is the moment you've all been waiting for. First, I think Jess is going to share the results of the first poll.
That populating there, Troy?
Yeah, so I can see it. Yes, I think everybody can see. Jess, what's the right answer?
Yeah, so if global healthcare sector were a country, it would be the 5th largest greenhouse gas emitter on the planet. So 5th was the right answer. So all those who answered to 5th, we'll put you in a random drawing for the chance to win a copy of the guidebook.
All right, and I think we are ready for our second door prize now. As exciting as a copy of the guidebook is, if you won both that first prize and this second prize, it would make your day. I believe, correct me if I'm wrong, Jess, but the prize for this one, for this question, is a 20-minute virtual coffee with one of the authors. So imagine your virtual coffee in one hand and your guidebook in the other hand, and you'll know that you want to get this question right. So the question's on your screen. It says, in a hospital, which of the following sources is often the greatest energy consumer, thus a great opportunity for impact? Domestic hot water, reheat, medical equipment, or HVAC fans?
And the authors are not supposed to vote, by the way. Just FYI.
I had to hold back.
I know. I knew you were going for it.
I have Kim Shin's voice ringing in my ear as I think about that question.
Okay, I think we can end the poll, Troy.
I think a good question would be what's number 2?
Oh.
Very, very, very nice. Well, I think you can see the results in front of you, but we'll come back with the results a little bit later. We now have the opportunity to hear from our authors, and so if you have questions, please do put them in the chat. You know, I have the privilege of asking the first question today, and I'll say that one of the reasons this launch party happened is because I was telling somebody about the guidebook. They will remain nameless, and they asked, "Well, Troy, is there a good way to get started with the guidebook? I have this guidebook. I'm going to go and buy it right away. But is there kind of a nugget or a tidbit or something that you can tell us that can make the guidebook feel more accessible and get us excited and get us kind of going on our journey?" For me, the person said, as well as for the various types of folks that they work with. And so in some senses, that's the first question that I would like to ask our authors, and it'd be helpful if we heard from each of you in this fireside chat situation, if you please. And so the question, however you want to interpret it, simply is, if you were advising somebody on how to get started or how to think about using the guidebook, what would you tell them? Oh, there's the book. Thank you, Kim.
Well, I don't mind jumping in because it's an easy answer. I always start with the pictures and go from there. See what looks, pictures, charts, graphs, see what looks the most interesting, because you'll get a smattering, a light smattering of all of the ideas. Although realistically, this guide is oriented towards several different audiences within ASHRAE, ASHE, and beyond, really. And so it may depend a bit on where the reader is coming from and if they have any familiarity with the information before. If not, then really truly starting at the beginning with the foreword. And the foreword is really quite compelling. I usually skip the foreword. I would encourage people to not do that this time. And then from there, go with the areas that really pique your interest first. Walt apparently disagrees, though. This is common. Walt and I frequently disagree in a good way.
Creative tension. No, I don't disagree at all. I'm doing a yes and. What I was going to say is that one of the things that I think was special about this book, and Thomas mentioned it, when he mentioned that this is the first time ASHRAE has done a collaboration with an organization like ASHE. And I think that was actually a really important part of what I think is in this book. And I'm getting to a real answer to your question here in a second, but because what I want to say is, what ASHE brought to the table was that this is not a theoretical exercise. This is not, in a way, what's the best design that you could possibly do. This is about how do you make something that's going to work. And so, the choice of Tim, a hospital engineer who's been managing healthcare for a long time, I think was very intentional. And there was I feel like a really heavy emphasis on doing things that worked. And so a big chunk of the guide that we haven't really talked about, but is on how to operate and maintain these things once they exist. And it occurs to me that particularly those of us in the design world, if we were to almost start from a perspective of, like, how does this stuff work in real life? It might help us think more than about the designs that we create. So I think that might be an interesting place to start.
I'll just jump off from there. I think taking the book as what it is, and that is an example of how to get all the way decarbonized, and taking a look at the big areas of opportunity in a hospital that could be decarbonized, and bouncing that against your design practice, a project you've worked on, or a hospital that you operate, and thinking about where the opportunities are for you, your practice, your facility, and starting somewhere, recognizing that this is meant to be going all the way, and it's one answer. I think this is an evolving space, and this is the first version 1. Hopefully we'll have versions beyond that, and maybe even you can contribute to the next version and help us craft another layer to the guidebook. But I think being able to bounce it off of your practice and understand where there might be places you can chip away or big moves you can make.
I guess I would say if I was building a new hospital today, not the engineer, but the owner, I would make sure everyone on the design team has a copy of the book, and I would set the standard that this is what we're going to do. So figure it out. I think there's a lot of fear about being able to do it. People look at the boilers and they think, oh, well, there's so much energy being consumed there that we can't possibly do it. The electrical grid can't possibly do it. It'll cost so much more. And if you can overcome that first objection and see that it is actually possible, even if you don't get 100% of the way, probably not supposed to say that here, but even if you don't get 100% of the way, you can get a long way, and that is worth the effort. It's doable. It's been done before.
I want to do one more yes and if you'll permit me, Troy. There's another thing that I think is important to know about the guidebook is that ASHRAE wanted this to be a 100-page book. And it really wasn't possible to, in 100 pages, try to describe every single thing that a hospital could do to reduce its energy footprint. And so I do think it's important to know that what we tried to focus on in the book are the things that are unique to healthcare and or particularly fearful or worthy of being afraid of or something. Jim mentioned fear, and I think that's exactly right. And so I would say the other thing about this guidebook in terms of the first thing to do, because many engineers, right, one of the things that we like to think is the first thing to do is waste less. And that's a really good place to start, particularly in existing buildings. And I do want to point to the many other resources that ASHE has, that ASHRAE have to approach those problems as well. So, in some ways, it's a little bit like I feel like this saying what's the one thing you would dive into. It's a little bit like unraveling a sweater. As soon as we start with that first thing, there's a lot more to draw upon.
Great. Authors, thank you so much. That's why we're here, right? To celebrate the guidebook and to hear those nuggets of wisdom. If you have questions, put them in the chat. Apparently, if you have appropriate jokes, we're putting those in the chat as well. As I look around, I see a lot of people here who have made contributions to the guidebook. That I know of, right? And I'm sure many contributions were made that I am not aware of. But so many of you talked with the authors, provided case studies, in some cases provided data. I see one person who provided some expertise from Europe. And so I'm thankful that in some senses there's a global community that came together to help create this guide. And so I know in particular, Mara has direct colleagues who work in multiple countries, and was able to bring some of that perspective. And so, Mara, I didn't give you much warning, if at all. I'm not sure if you saw my chat, but I was wondering if you might think about and maybe talk about what you learned from kind of diverse experiences in environment, and how that influenced the outcome of the guide. And as that's true for Mara, I think it's true for our other authors. So I'm hoping one or two of the others will jump in as well. But Mara, first to you.
Yeah, no, that's a good question. So I've worked across most of the US from, let's see, Florida to Alaska. But 3 years ago, I joined Dialogue, which is a mostly, although not entirely, but mostly Canadian architecture and engineering practice. And I'm working on a number of large hospital projects in Canada, including in really remote and very, very cold places. Places that regularly hit negative 40 degrees Celsius and Fahrenheit, it's the same, which was really beyond most of the work that I had really deeply engaged in previous to that. It's been really quite eye-opening to me to see what the different types of challenges are. We think climates like Michigan, where I've worked before, New York, et cetera, are very cold and can't decarbonize as a result of the weather patterns. But that suddenly looks really straightforward and really easy. And so we framed some of our conversations around, what is and isn't realistic around kind of those bookends of the conversation. The other factor that really helped to contribute to some of this is that, culturally, Canada may be sometimes partway between the UK and the US. And one of the ways that they're culturally closer to Europe is their mindset around climate change, both carbon emissions reduction and climate resilience. So for years, long before we were really heavily focused on this in the US, for years, their health authorities have had, in many parts of the country, regulations related to using carbon as the metric and not energy. Whereas we've focused on energy use reduction, they've focused on carbon reduction, and have also really focused legislation and regulation around appropriate strategies for climate resilience. So I definitely pulled from a fair bit of the good work that's happening in Canada, particularly in British Columbia, but elsewhere as well, as a resource for developing portions of the guide. But I have not yet had to visit Alberta in negative 40-degree weather, so I'm off the hook so far.
Excellent. Thank you, Mara. Walt, Jim, or Heather?
I'll yield to others, or I'll say something. All right. The thing I would point to, you mentioned the Sexton Foundation earlier, Troy, and we do a lot of work around the world in disadvantaged places. And one of the things that I think is important, really important to remember, because we often think about decarbonization and equity in the same breath. And, often it's really hard to think about, well, how do you do equitable decarbonization, right? What does that mean? How does that work? And, I have been to villages that were washed away because in places in Africa, the dry season is longer and drier and the ground gets dry, and the wet seasons are wetter and more intense and flood the villages and drive people away. And it strikes me that the entire enterprise of decarbonization, and more aggressive even than the 50%, which seems so hard, is just inherently an equity effort. And so I think the thing that's sort of always in the back of my mind is we almost can't go fast enough because so much rides on it. And I think it's worth keeping that in mind.
Great. Excellent. Thank you. Thank you, Walt. Steve, go ahead.
Hey, Troy. So just want to congratulate the authors on an excellent job. Very excited to have been part of this. One thing we haven't, I think it was mentioned earlier, I think Jim, maybe you sort of mentioned, the cost factor, and that you can get awful far at a very reasonable cost. Maybe you can't get to 100% without starting to spend some money. But what we often don't talk about is the social cost of carbon. And while that's not a cost that lands on your ledger, or if you're an owner, it's definitely a cost that you should take that I think should be taken into account. And the federal government has established a social cost of carbon. If you want a number that is vetted, it's out there. And if you start looking at the social cost of carbon versus the alternatives, suddenly things that seemed expensive are actually fairly inexpensive, and you have a payback. And then when the social cost of carbon gets internalized and the government does what it might need to do, which is pass a carbon tax, then you're going to be in a real world of hurt if you haven't thought about it ahead of time. So I just thought I'd put that out there.
Well, we only have time for one or two more questions. And for this question, if there's none in the chat, I'd like to ask our authors to imagine a little bit. So if the guidebook is as wildly successful as you might envision, what do you think the future could look like in the next 5 years, 15 years, and 25 years?
I'll jump in first on that. I think in the short run, we'll have some fantastic examples to be able to show of hospitals that have decarbonized. And they've done it and they're running and they're a fantastic place to be for the staff and patients and visitors, and they have a lower footprint. I also think that we'll have a new paradigm of what's normal, right? What is standard design? And hopefully what we're proposing in this guide doesn't feel radical anymore, but it's just what we do. And I think we've seen that with energy efficiency over the last, say, 15 years with hospitals and energy codes. And I hope over the next, I don't remember what time frame you said, Troy, but 5 to 10 years, we'll see that with decarbonization as well.
And I would add that it's not, if we're really truly wildly successful, it's not just about hospitals anymore either. There are some things that we put forward, some ideas we put forward in the guide that are, relatively straightforward and somewhat conventional, and other things that ask the reader to stretch a little bit, to think about the way we design and operate buildings a little bit differently from what we're used to. And so Heather talked about the new normal. I believe that new normal can easily be applied to other ways that we do things, other types of buildings, other aspects of facility operations and maintenance. And so I think the success here could start small, but then trickle out to have a much bigger impact, the pebble in the pond effect. But that means y'all gotta read the guide and start living it. No pressure.
And I have to say that is the perfect segue into the end of our time. First of all, there's the answers to poll number 2. So as we mentioned, we'll do a random drawing amongst those who answered the question correctly, and you'll receive a notification from Jess and team with your winning prize. On the off chance that you don't win the guidebook is available for purchase. And so I think in a moment you'll see on your screen and in the chat links to purchase the guidebook. Now, we know that there's a cross of ASHRAE members and ASHE members on the call. And so we provided both websites for an opportunity to purchase the guidebook. So yeah, it's on your screen. There's a QR code and in the chat. If you're a member, there's discounts, hence the 2 different links. And so I just wanted to just once again say thank you to our authors, to our task force, to so many of you who provided input and information, and to others of you who are really focused on moving your hospital, your healthcare systems toward decarbonization. You've been on the cutting edge of moving it forward and are excited about how you might use this guide. And we're excited, as Heather just mentioned, to be able to hear your stories because they'll help spur other stories that ultimately make a decarbonized hospital the norm. Thanks for celebrating. Thank you, everybody, and enjoy the rest of your day. Cheers.